Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P2184 refers to a low-voltage condition detected in the Engine Coolant Temperature ECT Sensor 2 circuit. This component plays an essential role in regulating the engine's temperature by providing feedback to the Engine Control Module ECM or Powertrain Control Module PCM. When the PCM receives incorrect readings, it can negatively impact engine performance, leading to potential overheating or poor fuel efficiency. The ECT Sensor 2 is typically located near the engine coolant outlet, which allows it to monitor the coolant temperature accurately. Identifying DTCs is critical for automotive diagnostics as they guide technicians to specific issues that require attention. In this case, P2184 specifically signals that the voltage from the ECT Sensor 2 doesn't meet established thresholds, necessitating a thorough investigation. The ECT Sensor 2 is instrumental in relaying the temperature of the engine coolant to the PCM, which uses this data to optimize engine performance and emissions control. A malfunction, indicated by low voltage, can cause the PCM to misinterpret coolant temperature, leading to improper fuel mixture and possible engine overheating. Located on the engine near the thermostat housing, the sensor is crucial for detecting various engine operating conditions. Its failure can lead to erratic engine behavior and diagnostic trouble codes that detract from the vehicle's performance and efficiency. Therefore, understanding its placement and function is paramount for effective troubleshooting. Given that this DTC indicates circuit low voltage, troubleshooting needs to start at the sensor and continue through to the PCM connections, examining for faults that may cause this signal disruption. Several factors may lead to the DTC P2184 being triggered. First, poor connections at either the ECT Sensor 2 or the PCM can result in intermittent signals, contributing to low voltage readings. Moreover, if the terminals are loose or corroded, they may fail to transmit accurate voltage levels, resulting in erroneous DTCs. A direct fault in the ECT Sensor 2 itself can also lead to low voltage output. This component can wear over time due to extreme temperature changes. Furthermore, wiring issues along the TW2 SNSR/TW2 line connecting the sensor to the PCM are common culprits. A short circuit or break in this wire could bring down the signal voltage level, producing the same code. Understanding these causes provides a strong foundation for methodical troubleshooting, ensuring all areas of potential failure are addressed systematically. The symptoms linked to DTC P2184 can significantly impact the vehicle's operation. One primary indication is engine overheating, as erroneous temperature readings from the ECT Sensor 2 may mislead the PCM into thinking the engine is operating at optimal temperatures when it is not. Consequently, the fuel injection system may not respond adequately, leading to poor fuel efficiency, which can translate to increased operational costs for the driver. Other observable signs could include erratic engine behavior, such as stalling or rough idling, stemming from improper fuel-to-air mixture ratios dictated by false data from the ECT Sensor 2. Thus, recognizing these symptoms is vital for timely diagnosis and repair, preventing further damage or costly repairs down the line. In the first troubleshooting step, it's essential to turn the vehicle to the on mode without starting the engine. Once in this state, you will check parameters associated with the ECT Sensor 2 using the Honda Diagnostic System, HDS. Specifically, you need to monitor the signal voltage. A reading of less than 0.08 volts signifies a fault in the circuit. If the parameters match the threshold conditions you've identified, It confirms that the failure is legitimate, and you should proceed to the subsequent troubleshooting step. However, if the voltage readings are satisfactory at this moment, it may indicate an intermittent issue. In such cases, close attention to wiring and connections is necessary, as dust or moisture ingress could disturb the readings sporadically. Your goal here is to ensure you gather concrete evidence of the malfunction for an effective next step. For the second step, you will again turn the vehicle to the off-lock mode to ensure all circuits are inactive. Next, disconnect the ECT Sensor 2 2P connector, which will not only isolate the sensor, but will also allow you to check its output without interference from the system. After disconnecting, turn the vehicle back to the on mode and again assess the parameters with the HDS. You are primarily looking for the same value of less than 0.08 volts for the ECT Sensor 2. If the anticipated readings are met, you can safely proceed to the next troubleshooting step, where you will conduct further checks. However, if the readings indicate that a voltage is being outputted, this will indicate a faulty ECT Sensor 2 requiring replacement. Understanding these values helps you delineate between sensor-related faults and issues within the wiring harness or PCM. The third troubleshooting step begins by placing the vehicle in the off-lock mode again. After ensuring the vehicle is inactive, the next action is to jump the SCS line with the HDS. The SCS, or Service Check Connector, is used to access the vehicle's diagnostic system for troubleshooting purposes and ensures that certain DTCs are properly diagnosed. Following the successful SCS line jump, you must disconnect PCM connector A51P to isolate the PCM from the rest of the electrical components. With both the ECT Sensor 2 and the PCM connectors disconnected, you will then check for continuity between two test points: the ECT Sensor 2's second terminal and body ground. If you find continuity in this circuit, it signifies that there's a short in the wire connecting the ECT Sensor 2 to the PCM, necessitating immediate repair. If continuity is not present, you can conclude that the wire connects correctly, and you may want to explore other diagnostic avenues, including consulting authorized information for further diagnostics. After completing the necessary repairs indicated in earlier troubleshooting steps, it is crucial to verify the effectiveness of these repairs. Begin by rechecking the function of the ECT Sensor 2 to ensure it is providing accurate voltage readings below the defined threshold. After confirming functionality, the next logical step involves clearing any previously stored DTCs from the vehicle's system using the HDS. Following this, preventive maintenance is essential in ensuring that issues like DTC P2184 do not recur. One effective strategy is to conduct regular inspections of the ECT sensor and its wiring harness. Inspections should include looking for signs of wear and tear, corrosion, or loose connections that could lead to intermittent faults. Keeping connectors clean and free from dirt or moisture greatly enhances the longevity and functionality of these electrical systems. As such, contamination can lead to poor connectivity and erroneous signals. Furthermore, vehicle owners should pay attention to any unusual symptoms sooner rather than later, allowing for proactive repairs rather than reactive ones. By fostering a culture of maintenance and awareness, particularly of the ECT sensor and its associated wiring, vehicle owners can ensure long-term reliability and performance of their Honda Pilot. In summary, successfully addressing DTC P2184 revolves around a deep understanding of the ECT Sensor 2 and its critical role in managing engine temperature. Following a structured troubleshooting approach not only assists in identifying the root cause of the low voltage reading, but also provides a clear pathway for rectifying the issue, whether through direct replacement or wiring repairs. The symptoms associated with this trouble code may significantly impair vehicle functionality, rendering it essential to act decisively and accurately. Finally, emphasizing preventive maintenance, including routine inspections of the ECT sensor and its wiring, can mitigate future problems, ensuring the Honda Pilot remains reliable and efficient. By adhering to these principles, both technicians and vehicle owners can achieve a smoother, hassle-free driving experience. Please like and subscribe to the channel. See you next time.